So welcome everyone. We'll begin. Hope you're all well. Today, Friday afternoon, my plan is just to address 2G. So we're just going to talk about this exercise today, and then there'll be this won't take long, and there'll be lots of opportunity to catch up, see how we're all going, go through a couple of questions with each of you on the board. That's our plan for the lesson today. So we only differentiate, when we say logarithmic functions, we only differentiate the natural log. We don't need to worry about other logs in base A. So the derivative of a natural logarithm, okay, if we just have ln of x, the derivative is 1 on x. Okay, we're going to get straight into using that. And if we have ln of a function of x, then the derivative is the derivative of that function on top of the function. Okay, really easy. These are one step. We'll get straight into it. So if we're looking at this one, we've got 3x times ln x. 3x times ln x. Whenever we see times, we have to use the product rule. So we'll identify A, we'll identify B, U and B, so U is 3x. Alright, the 3 is just a number, so it can belong to the x. We could just keep it right out front as well if we wanted to. So then our U dash will be 3. And our V dash, alright, we have ln of x, the derivative is 1 on x, so V is ln x, V dash is 1 on x. And then we just bring all of that together. 3 ln x, U dash V, plus U V dash. There's our answer. Over here, this will simplify. X times 1 on x will just become 1, so that will simplify to 3. We don't need to simplify that. All right, then for B, we have ln of f of x. We've got some function in the brackets here. So we're going to differentiate this in one step. All right, the derivative is, if we have y is ln of f of x, we take that function and we put the derivative at the top. So I'm looking there, 3x squared take 2x, the derivative will be 6x take 2, and then it's just on top of that function, 3x squared take 2x. Alright, so just again, we've got ln of a function, we put the derivative at the top and the function at the bottom. That's all we're doing with that one. Okay, on to C. Now here, we're going to use the product rule again. We have e to the 3x take 2 multiplied by ln of the square root of x take 5. Here, you can see we're compounding the product rule, we've got derivatives of exponentials, and we've got derivatives of logarithmic functions. So we're bringing all those skills together. You'll see how it all compounds beautifully, and we get to refresh everything we've done. So U is our first term, e to the 3x take away 2. V is our second term, and I'm going to write V in two ways. Okay, I'm going to get you to think about it. Firstly, I'm going to write it as ln of x take 5 to the power of a half. And if we can simplify things using log laws, then we absolutely should. And so that half can come out the front, can't it? We can call that half ln of x take 5. They're equal to the same thing. And what that's going to do is that's going to save us from performing the chain rule. All right? You can still do it using the chain rule. It's just going to be a fair bit longer. We should always look for the simplest way to do things if we can see it. Okay, so we've got U, we've got V. Just quickly, if you have e to the f of x, the derivative is f dash of x, e to the f of x. Okay, here we have e to the 3x take 2. So then u dash is going to be, well, the derivative of 3x take 2 is 3. And then we just keep the e to the f of x. All right, so that's what we did on Wednesday. So there's our u dash. And now we're ready to do our v dash. So if I've got v, here it is here, I'm going to use this form. We've got half times ln of a function. The half is just going to hang out. And then I've got ln of x take 5. So, ln of a function, we put the derivative of x take 5 at the top. Derivative of x take 5 is just going to be 1. And then the function at the bottom, x take 5 at the bottom. So we've got all of the parts there, we'll bring them all together. U dash v U dash v plus u v dash. Okay, so I did say here you can just differentiate from that step. You would have ln of a function to the power of n. So you'd be looking at that function to the power of n. That's when I have to use the chain rule. N f of x, n take 1 at the top, and then f of x at the bottom. So you can do it that way. It is much faster this way. Not much thinking involved. All right, I'm going to clear off A and B so that we can do D. Okay, so we have f of x is, and we have the cubed root of ln of x to the 5 take away 2x. Okay, so before we differentiate this, we should think, all right, I've got the cubed root of a function, the cubed root of a function. So that means I've got a function to the power of a third. Okay. Now this, all right, you have to be careful here, because here we have the whole function to the power of a third, right? Over here, we only had the x take 5 to the power of a half. So here is where we can pull that power out the front. Here we can't do it because the ln is part of the power as well, okay? So just to make that point really clearly, all right, and I've had this written down before, ln of x squared, we can write it like that, is equal to ln of x squared. We can write it like that. But it's not equal to ln of x squared. Okay? Here is the circumstance where we can bring the power out the front. Here is the circumstance where you cannot, because the whole thing is squared. Squared applies to it. Similarly, here, this third applies to the whole thing, so we can't bring it out the front. That means we've got a function to the power of n, so now we do have to use the chain rule. A function to the power of n. So, the chain rule, as we're using them, I'll refresh you with them. If we have a function to the power of n, then the derivative is n, f of x, n take 1, f dash of x, okay, on the back of our sheet, right? So, function to the power of n, let's write the derivative. F of x goes to f dash of x. So, n, the third comes out the front. F of x, n, f of x, n take 1. And then n, f of x, n take 1, multiplied by what's inside here, the derivative of what's inside here. So then we're just focusing on the ln of x to the 5 part. Alright, so you can see we've got chain rule compounding with derivative of a logarithm. ln of f of x. Alright, ln of that function. Okay, if we have ln of f of x, this is what it goes to. So x to the 5 take 2x, the derivative of that is 5x to the 4 take 2. Alright, that's what's going to be at the top. And then x to the 5 take 2x at the bottom. Okay, so that's quite a tricky one. There's a lot of rules going on there, right? We've got the chain rule, n f of x, n take 1 times f dash of x. And then in here we're doing a derivative of a logarithmic function. Direct application of this rule. Very good. Okay. So, everyone okay for me to give it a clear here? Alright, so question 2 then given f of x equals x cubed on top of, ln of x cubed on top of x plus 2. Show that f dash of x is this. Now there's two procedures we can use here. And remember I've said, if we can simplify things using log laws, we should. We should always use log laws to simplify when we can. So I'm looking at this and I'm going, I've got the logarithm of a fraction. Remember, ln of a on b is equal to ln of a take ln of b. Alright? We have that rule with a product as well. ln of a times b is equal to ln of a plus ln of b. So I'm looking at this and I'm going, we can manipulate that function. We can write that as ln of x to the 3, take away ln of x plus 2. Very good. And now we can differentiate it in one step. We don't need to consider a product rule or anything like that. So if I have, even here, ln x to the 3, maybe there's even one more thing I can do. ln x to the 3, we can think about that as 3 ln of x, right? Because that 3 only belongs to x, we can bring that right out the front. The only time you can't do it, and they'll be very clear, is the whole thing will be in brackets. Okay? Here, it belongs to the x, so we can bring it right out the front. 3 ln of x, take ln of, and I should be putting brackets around here, sorry, to demonstrate that the 2 is part of the logarithm. Alright, it's ln of that whole thing. Okay, so that's still the function. Let's differentiate it. So the derivative of ln x is just 1 on x. And then the derivative of ln of x plus 2. It's ln of f of x again. So we have the derivative at the top, x plus 2, the derivative is 1. And then the function at the bottom, just x plus 2 at the bottom. Okay, so that's the derivative, all right? And we wouldn't normally need to simplify, except in this circumstance it says, show that the derivative can be arranged, and they've given us a form that they want us to get. So, what we have at the moment then is we've got 3 on top of x, take away 1 on top of x plus 2. That's what the derivative is. I've just multiplied the 3 to the top of the fraction. Right, a number times a fraction will always go to the top. Now, if we're going to bring these together, we need them to have the same denominator, right? So we're going to cross multiply the denominators. I'm going to multiply this one by x on x, and I'm going to multiply this term by x plus 2 on top of x plus 2. Okay, so we're cross multiplying the denominators. That one's going here, that one's going here. Okay, I'll do it in a series of steps so we can see what we've got left. So, they have the same denominator, so we can bring them together over that same denominator, right? So we have 3x plus 6, I'll expand it now, 3x plus 6, take away x, all on top of, and I'm even going to expand the denominator, x squared plus 2x, and this gives us 2x plus 6 on top of x squared plus 2x, which is what it said to show that the derivative is. Now the good thing about these as well is sometimes it'll say show that the derivative is this, and the reason we do that is because sometimes you need to use it a bit later on. Like this is part A, show that the derivative is this, you do it, and then part B, hence use the derivative. So that even if you can't get this part, you still get the subsequent marks because you've got the equation that you need. Okay, so this is going to be the easiest way to differentiate it, right? But even if you don't use the log laws, you can still differentiate it. All right, you still have ln f of x, and if you're going to differentiate that function, you would have to use u divided by v, you have to use the quotient rule, but it will end up being a much bigger mess because you've got u on v, and then on top of another fraction, you have one fraction divided by another. But it will still all come out in the wash, and you will be able to get to it. Okay, so where you can use the log laws, the questions will prompt you in the textbook, look to use the log laws. Really good. Okay, that's all from me. So that's 2G. That's where I'd like us to orientate our efforts today. But I'll float around, just make sure we're all up to date, feeling okay about 2E as well.